Hello friends, welcome to the second video on Laplace transform. This video will help you to identify few properties of Laplace transform and how to apply them effectively to the given problems. Come on, we will move into the video. The first property we are going to see is called as first shifting property, which is stated as Laplace of e power minus at into f of t is Laplace of f of t with s shifted to s plus a. We call it as like whenever there is going to be a function and along with it there is an exponential attached along with it. Exponential takes an upper hand and it computes the Laplace of the function replacing s with s plus a. So if it is going to be minus over here, it is going to be plus over here. If it is positive here, then this becomes negative. Let us now apply it to a simple problem and see how this works. Let us find what is going to be Laplace of e power minus 2t into sine phi t. So now this is my e power minus at and this is going to be my f of t. Now what does this exponential function do is, it computes the Laplace of sine phi t and to whatever be the answer which this gives, and this answer which contains s, this s is shifted or moved by how many units? S plus 2 units, because there is minus sign here, so it moves to plus 2 units. And we know from our prior video on the basics of the formulas, what is Laplace of sine phi t? If it is s here, then it has to be constant in the numerator. So what is going to be the constant? It is going to be phi. So it is phi divided by s square plus phi square. So this is my Laplace of sine phi t. And now what does this exponential function do? It shifts wherever it finds s with s plus 2. So now this gives me phi divided by s square plus 25 when I expand this with s moving to s plus 2. Hence, it provides me with phi divided by, where do I find a s? Here I find an s. So this s over here is replaced with s plus 2, the whole square plus 25. So, in general, whenever we have an exponential function, this always takes an upper hand, computing the Laplace of the leftover function and then pushing the s by s plus a units. Now, let us take one more example. Number 2. Find Laplace of t square e to the power of 3t. Now what does this does? There is going to be one term over here f of t and there is an exponential term. So by the shifting theorem, it computes Laplace of t square and in the output wherever it finds s, this s is moved by how many units? Since it is positive 3 over here, it moves to minus 3 units in the s direction. So this gives me what we know about Laplace of t square. Laplace of t square is nothing but 2 factorial divided by s to the power of 2 plus 1, which is 3. So here s is shifted to s minus 3. And we know that 2 factorial is going to be 2 with s cube moving to s minus 3. So the final answer will be 2 divided by, what is happening to this s? It is replaced with s minus 3. And what you have on power over here, this is going to be your cube. So the final answer will be 2 divided by s minus 3 the whole cube. I hope you have understood the first shifting theorem. Now let us move on to second property of your Laplace. This second property is called by the name derivative of transform, which states that Laplace of t power n f of t is minus 1 power n d power n by ds power n into Laplace of f of t. When f of t is multiplied by t to any power of n, then it is taken derivative n number of times for the Laplace and then multiplied with minus 1 power n. Now, let us apply it to problems and see how this formula works. Let me find the first problem for find Laplace of t into sine 3t cos 2t. So now what happens along with the t? You have something over here. Let me treat it as the function f of t. So by the formula, what happens? This is going to be nothing but t. What is the total power of t over here? It is going to be equal to 1. So now this gives me n is equal to 1 for me over here. So it is minus 1 to the power of 1 d power 1 by ds to the power of 1 Laplace of sine 3t into cos 2t. So this is my content. Now as such I have only Laplace for simple sine 3t or a simple cos 2t. But now this is in a product. So this trigonometric quantity has to be now converted into its equivalent where I can convert or apply individual Laplaces too. Now we will have to recollect the formula sine A cos B. What is going to be sine A cos B? It is half sine A plus B plus sine A minus B. So we will try to apply this formula. So it is minus 1 the whole power 1 d by ds of, now this I am converting, I have a Laplace of half times of sine A plus B. 3t plus 2t makes it as 5t plus sine A minus B. 3t minus 2t makes it as t. So now for this I need to find Laplace and then take the derivative of it. So now what will happen? This half being a constant, I can take it outside. So it comes out as minus half because I have a minus 1 power n. Now this becomes d by ds of Laplace of sine phi t plus Laplace of sine t, for which I need to find the derivative. So this gives me d by ds of, what is Laplace of sine phi t? This is going to be, if it is s, there is going to be constant over there in the numerator. S squared plus 25. What is going to be the next term? Laplace of sine t. And what is Laplace of sine t? 1 divided by s square plus 1. Now what happens next is, I will have to differentiate this quantity. On differentiation, what will happen? This gives me minus 1 by 2 into, you can take this s square plus 5 to the numerator and d by ds of s square plus 25 the whole power minus 1 plus 1 into d by ds of s square plus 1 whole power minus 1. Now let us start our differentiation. So this gives me 5 times of minus 1 into s square plus 25 whole power minus 2 into s square on differentiation is 2s plus, what happens to the next term? This is minus power 1. So minus 1 s square plus 1 power minus 2 into s square on differentiation is 2s. This 2 over here can be cancelled off with this 2 in the denominator. This minus sign and minus sign can be cancelled off with this minus sign. Hence, the final answer for you will be equal to 5 times of s. This minus 2 will come to the denominator as s square plus 25 whole power 2. What happens in the second term? I have a single s. So this becomes s divided by s square plus 1 whole power minus 2 gives you s square plus 1 whole power 2. So this will be my final answer when I take it for the derivative with t to the power of n. Now let us try to apply it to one more problem. Let me find what is Laplace of t square into e power minus 2t. Now this is going to be a kind of problem where I can apply exponential to my t square or find the derivative to my e power minus 2t. In both ways, it will give me the same answer. First, let us try what will happen if I apply exponential shift. I know that this is nothing but Laplace of t square where s is shifted to s plus 2 because it is minus sign over here. We know t square is nothing but 2 factorial divided by s cube where s moves to s plus 2. So this is nothing but 2 divided by s plus 2 the whole cube. This is by your first shifting theorem. Now let me apply the theorem or property of derivatives. It is power 2. So what will happen? I can rewrite it as minus 1 the whole square d square by ds square Laplace of e power minus 2t. Now minus 1 the whole square makes it as plus 1. So d square ds square of what is Laplace of e power minus 2t? It is 1 divided by s plus 2. So this s plus 2 has to be differentiated how many times? 2 times. Come on, let us differentiate it one time first. So if I differentiate one time, it becomes d by ds of this s plus 2, the whole inverse on differentiation gives me minus 1 into s plus 2, the whole power minus 2. Now I'll have to differentiate one more time because power is 2. So it is second order derivative. So minus 1. What is s plus 2 power minus 2 on differentiation? Minus 2 into s plus 2 the whole power minus 3. So now this gives me minus 1 into minus 2 is 2 divided by this minus 3 when it comes in the denominator comes as s plus 2 the whole cube. So see, we have got the same answer whether we use exponential shift or by the formula of derivatives. So whatever be the process, in whichever order the evaluation is carried out, the final answer will always be the same. Thank you.